Alright folks, in this video is about galvanic cell, and I'm gonna show you two examples of galvanic cells and how we identify the cathode, anode, and the electron flow direction, cell notation, those kind of things. Let's take a look at the first example. Iron plus iron 3 plus, it generates iron 2 plus. Okay. Question A. Write the two half fractions. You need to identify what is oxidized, what is reduced. Iron oxidation state is 0. Iron 3 plus oxidation state is positive 3. Iron 2 plus oxidation state is positive 2. So iron solid is oxidized. Iron 3 plus is reduced. Therefore, let's do A first. The oxidation half fraction, okay, would be iron solid to iron 2 plus. And if you count the charge of the two sides, you will see that you need 2 electrons to balance the charge. Okay, and the reduction, that would be the iron 3 plus to iron 2 plus. Iron 3 plus to iron 2 plus. And if you take a look at this balanced ionic equation, you have 2 iron 3 plus, so 2 iron 3 plus, and you have 2 iron 2 plus, okay, on this side, because you've already used the 1 iron 2 plus in the oxidation half fraction, so you have 2 iron 2 plus left. Now again, if you count the charge of the two sides, you will see that you need 2 electrons on the right-hand side to balance the charge. Alright, if you add these two half fractions together, you will get the same balanced net ionic equation on the top of this slide. Okay, so this is A. The second question B, label anode, cathode, and electron flow direction. Once you identify what is oxidized, what is reduced, you can identify the cathode and anode. Remember, the anode is an electrode that the oxidation half fraction happens, okay, and it can donate electrons. So iron is oxidized, it generates electrons. So here iron bar in this structure would be the anode. Alright, anode. And of course the platinum would be cathode. And remember, platinum is not part of the reaction. The function of the platinum itself is just transferring electrons, okay? But please remember, electrodes are solids, okay? So, and the electron flow direction, because anode generate electrons, so electron is going from anode to cathode. So this is the direction of the electrons. Question C, write the cell notation. Like we discussed in our lecture, when you write the cell notation, you start from the anode. So iron is the anode, phase boundary, and the iron 2 plus, that is the iron, that is the ion involved in this oxidation half fraction. Okay, and between the solid state and the liquid state, there is a bar, the line here, to tell people that these two are in the different phases. Okay, and then so this is oxidation. This is anode with its ion. Now, between the cell with the anode and the cell with the cathode, you use a double bar to represent the salt bridge. Okay, the salt bridge between the two cells. On the cathode, and the cell with cathode, you have 2 ions, okay, iron 2 and iron 3. So you write both of them because both of them are in the same phase. And iron 3 plus. Okay, you may ask me why we ignore nitrate. Nitrate is a spectator ion. It's not part of the oxidation reduction reaction, so you can ignore it when you write the cell notation. Alright, so these are the 2 ions in the aqueous solution. Now it's time for us to write the cathode. Again, because cathode is a solid, so you use a use this bar to represent the different phases between the aqueous solution and the platinum solid, the cathode. Alright, so this is a cell notation for this galvanic cell. Last question D, label the direction of the ions in the salt bridge. When you look at this salt bridge, you have two ions, sodium cation and nitrate anion. Nitrate anion has a negative charge. And when you look at this electron flow, it goes from your left side to right side. Okay. In order to finish the loop, close the loop, the charge, the negative charge in the salt bridge has to move this way. So the whole thing, the whole negative charge is running in the clockwise direction. Okay. So cation is going to the opposite direction, the anti-clockwise direction, to close the loop. All right. So this is how we identify the directions of this ions in salt bridge. This is example 1. Let's see example 2. Iron solid plus proton to generate hydrogen gas and iron 2+. Again, oxidation state for iron solid is 0. Proton oxidation state is +1. Hydrogen gas oxidation state is 0. Iron 2+ oxidation state is +2. Write the two half fractions. Okay, so again, oxidation half fraction would be the iron solid to iron 2+ in aqueous solution. And again, you need 2 electrons on the product side to balance the charge. Reduction would be the proton to hydrogen gas. You have 2 protons in aqueous solution to hydrogen gas. Okay, and if you count the charges, then you need 2 electrons on the reactant side to balance the charge. Now we know iron is the electrode that donates electrons, right? So here you have iron bar. Of course, this one would be the anode. And here, this side, you have a very special electrode. It's a glass tube, and inside in this glass tube, it has a platinum wire, and this platinum wire would be the cathode. And because cathode, the electrodes, they have to be solid. Okay, so and the electron flow direction from anode to cathode. So on the wire, electron goes from your right side to left side. Question C, write the cell notation. Again, we start from anode, iron solid. The phase boundary, iron 2+ in aqueous solution. And then salt bridge. So here, as you can see, in the cell with the cathode, it generates hydrogen, right? So in aqueous solution, you have proton, that's for sure, okay? You have proton, which is positively charged. All right, let me make sure that this is positive. And then how about the gas? Gas is in the hydrogen gas is in the gas phase, so you need to use a phase boundary to isolate the hydrogen gas from the aqueous solution. And then you have the third phase, and that is a platinum, okay, cathode. So as you can see, in the cell with this cathode, you have 2 phase boundaries because you have 3 phases. All right, this is a cell notation. The last question, label the direction of the ions in the salt bridge. Again, because electron is going this way, anti-clockwise, right? So the negatively charged ion, NO3, okay, this one should be NO3. NO3 minus has to go to this side to finish this loop with the anti-clockwise direction. Of course, the potassium cation will move to this side to balance the charge in this cell with a cathode. All right, I hope this video can help you understand the structure of the galvanic cells a little bit better. Please let me know if you have any questions, and I would be very happy to help you. Thanks.